All right, let's do this pretty fun problem called find the duplicate number. I really like this problem because there's a number of ways you can do it, and it's gonna be pretty fun to see the different approaches and the trade-offs. So essentially, the constraints are that we have a nums array containing n plus 1 integers such that they're within this range 1 through n inclusively. This property is actually quite important, and you'll see how it plays into one of our solutions. So as the name of the problem suggests, we're given a nums array and we're told to find the duplicate number. In example one, it's pretty easy to see that the duplicate number here is the number 2. Another example I want to note is the following. So here the duplicate number would be the number 3, and that's what we would return. So essentially what I wanted to indicate here was that the number that is considered the duplicate number doesn't just repeat twice, it can repeat up to n times. Now, I know the problem statement has the following constraints to solve this problem without modifying the original array and to use constant space. But let's just ignore these constraints for now and really play around with the problem, and we'll slowly build up to a solution that can satisfy this. So probably the easiest way to do this problem is to use brute force. Basically, the idea being we're going to take this nums array uh, and we're going to loop over the nums array for each element n times. So let's run through a simulation. We start at the 1 here, and we're going to check through the remaining of the array that, hey, does this 1 repeat again? We do this for each element, and we realize that, hey, nope, this is a distinct element. So we're going to move on to the 3, and we're going to do the exact same thing. We're going to check, hey, does it repeat again? Does it repeat again? Does it repeat again? And it doesn't, so it's a unique element. And we continue doing this throughout the array until we get to the 2, at which point, now when we check, we're going to see that, hey, yeah, this number is the same, so it is the duplicate number. So not a lot of drawing for this solution, and I think it'll make more sense in the code section, but pretty simple and straightforward. To evaluate the time complexity for this, because we go through each element, and we do a pass through the array for each element, it's an O of n squared time complexity. And for the space, we don't actually make use of any extra space or any data structure, so it's O of 1. Okay, let's do it on LeetCode now. So following our example, what we're going to do is we're going to go through each element in the nums array. So for I in range length of nums, and then we're going to go through each element within the nums array again. One thing you have to make sure is you have to start the j pointer at I plus 1 because we don't want to have a false negative where we end up comparing 1 with 1 in example 1, for example, here. So now we're going to check is if the number at j is equal to nums at I. If this is the case, this is a duplicate number and we can return it. And that should be it. Now, to be honest with you, I don't think this is going to pass on LeetCode because it's too inefficient. We're probably going to get a time limit exceeded exception. That's okay. To go through the time complexity gaze, as you can see, we go through the nums array, and then for each element, we compare every element in the remaining array. All right, so I might have given this one away, but for the second solution, why don't we actually make use of some space and really try to optimize on the time complexity and avoid some repeated work. So for this solution, we're going to use the set, and we're going to use the set or hash map because these data structures allow us to search elements in O of 1 time, which is going to dramatically cut down on the time complexity. One thing to note, I think it's better to use a set here than a hash map because a hash map has a key value, but it doesn't look like we're going to be making use of this property. Instead, we're really just checking that, hey, have we seen this element before? And then making a decision based on that. Okay, so let's run through the simulation again. The only difference being this time is now we have the set object. So we're going to start at the 1 and we're going to check that, hey, have we seen it in our set before? We haven't, so let's go add it. We're gonna do the same thing for the 3. Check, have we seen it in our set before? We haven't, so let's add it. Now we're on the 4. We're gonna check that, have we seen it in our set? We haven't, let's add it. Now watch what happens when we get to the 2 here. We're gonna add it to our set first because we haven't seen it. Then we come to the second 2, we're gonna realize that, hey, we've seen this element in our set before. This must means that this is the duplicate element. Evaluating the time complexity for this one is pretty simple as well. It's going to be O of n because we just do a single pass through our nums array. And because this time we did make use of some extra space, it's O of n as well, because at most the size of this set will be n minus 1. Okay, let's do it on LeetCode now. So following the example, we're going to first create a set object. So I'm going to name this scene, and this is our set object. Now we're going to go through the nums array. So for n in nums, before we add it to our set, we need to check that have we seen it before. So if n is in nums, oh, is in scene, then this must mean that this is the duplicate element. Otherwise, we can add it to our set. And this one should pass. Time complexity, pretty simple to see. We do a single pass through the nums array, and because we do make use of a set, we have a space of O of n. So far we've done 2 solutions, one where we made use of extra space and one where we didn't. Now, if you think back to the brute force solution, it failed because it was too slow. Can you guys think of a way to make that solution a little bit better while also not making use of any extra space? So I don't know if this came to your mind, but this is really simple and kind of got overlooked, but it's to simply sort the array. Look what happens when we take the following array and sort it. By sorting it, all the duplicates are next to one another, and it's pretty easy to tell. So all we need to do now is go through the nums array with a window of size 2 and check if the adjacent elements are the same. So 1 and 2, they're not the same. Let's move our window. 2 and 2, they're the same. We found our duplicate element. The time complexity for this one is going to be pretty simple. Um, the window checking is really just a single pass, but most of our time complexity is actually garnered by the sorting algorithm we choose to use. Assuming we use a optimal sorting algorithm like merge sort, it will be n log n, and the space complexity would be O of 1. All right, lead code time. So we're going to first sort the nums array. Once sorted, we're going to run through the nums array with a window of size 2. -1 because we have that window of size 2. And now we're just going to check the adjacent neighbors. So nums at I is equal to nums at I plus 1. We found our duplicate, and we can return it. This one should probably pass. Nice. I think the time complexity here is pretty easy to tell. If we didn't make use of sorting and assumed that this nums array was already sorted, it would be of n because we do a single pass. But because we do sort it, it's n log n. So that's where most of the time complexity is being garnered from. Okay, so before we begin our last solution, I just remembered there is another sorting algorithm that takes advantage of this property, the fact that the numbers are between 1 and n inclusively. It's called cyclic sort, and this can actually sort the nums array in O of n time. I think this is a pretty cool sorting algorithm, and we could have definitely used it here, but I'll maybe use it again and showcase it more in a different problem. But yeah, for now, I think it's important to just call it out and let you guys know that there is a sorting algorithm that could have done this in O of n and reduced our time complexity down to O of n, but we would have still modified the array, so there's that. Okay, our final solution, I think you could argue that this doesn't really modify the array, but it still does in a way, and you'll see what it is. Essentially, it's negative marking. It also makes use of this property that we were given, and I think it will make more sense if I go through an example. So we're going to take this nums array and we're going to treat each element in the array as an index for the nums array. And I'm going to keep everything 0 index, so I'm going to subtract 1 from each element. So for example, we start at the 1 here. We're going to jump to index 0 and we're going to invert that value. We invert the negative we invert 1 to negative 1. Go to the next element 3 and we're going to do the same thing. Jump to index 2 and invert that value. Now we're on the next one, which is number 4. Which, by the way, make sure that when in code, when we're doing this, when we pull the element outside of the nums array, make sure you take the absolute value of it so we don't end up with negative indexes. So again, we're going to jump to index 3 and invert it. And now watch what happens when we come to the number 2. We're going to jump to index 1 and invert it. And then when we come to the second number 2, we're going to jump to index 1 again, and we're going to realize that, hey, this number has already been inverted. This means that the following number we're at is the duplicate number. Now this approach is obviously very clever, but it's actually used a lot of places, and you'll definitely see it come up again. The time complexity for this one's pretty easy to evaluate. Because we only do a single pass through the nums array, it's O of n. And because we also don't make use of any extra space, we do these changes in place. So it's O of 1 space as well. All right, let's just do it on LeetCode now. So what we're gonna do is we're gonna go through each element in nums for I in, or actually for each element in nums. So for n in nums, before we use this value, we need to make sure we take the absolute value of it in case it's already been inverted. And then before we invert the value at whatever index this is, we need to check that it's not already been inverted. If that is the case, that is the duplicate number. Okay? Otherwise, we can go ahead and invert the value at n. And that should be it. Time complexity, pretty simple. We do one pass of nums. We don't make use of any extra space. So O of 1. Now there is a final solution to this problem as well that does this in O of 1 space, O of n time complexity, and does not modify the array that we did in the negative marking solution. It is the quick select approach. I'm actually not going to be going over this solution because there's already a wonderful video on this available on YouTube. Um, so definitely watch that if you guys are interested. But this is really an uncommon algorithm, which is one of the reasons why I don't want to cover it. But yeah, this one will do it in O of n time and O of 1 space and does not modify the array. All right, with that completed, I did want to leave you guys with a follow-up for sure. So a follow-up question I have is, in this problem, we look to find the duplicate number. How about I ask you guys to find the single element inside the array? So the only element that does not repeat more than once. Definitely take advantage of some of the solutions we looked at today, and I look forward to what you guys come up with.